The title of our meta-analysis does no-till increase maize, sorghum, and wheat water use efficiency in the US. Introduction. Increasing water efficiency is a challenge for agricultural production, especially in the semi-arid regions. And no-till is a sustainable agricultural practice that has the potential benefits of soil conservation, as to reducing wind and water erosion. And also we haven't seen that the conventional till over time have been decreasing 30–40% of the total soil organic carbon. The objective of our meta-analysis was to investigate the impact of no-till on yield, evapotranspiration, and water efficiency of the major crops in the US. The hypothesis was the no-till soils have greater yield and water efficiency than conventional till soils, especially in no-till long-term durations. And also, we evaluate a range of agronomic and environmental factors affecting WE, ET, and yield. Material methods, the data were organized from studies where conventional till control could be compared with no-till treatments in the US. We used database Web of Science, Elsevier, and Google Scholars, and we use a set of keywords to find these studies. The keywords that we used was maize, sorghum, and wheat, tillage, water efficiency, or water efficiency, no-till, yield, and field, or tillage, water efficiency in the USA, and no-till and water efficiency. The study is also follow some criteria. For example, all the studies were conducted in the field conditions in the US. And the conventional till and no-till were conducted in the same experimental area. And also the data were extracted from the studies as a variable and included yield, evapotranspiration, and water efficiency. In this table, this is just a part of the table that we can see the studies that we found, and how we organized the data from each study. We also organized if the study was conducting a rotation or a single crop, the temperature, mean elevation, water supply, the precipitation in that experimental area, the number of replications, and the years of no-till. The figure one shows the distribution of the locations of the studies, including in the meta-analysis. In green, we can see the areas with sorghum, blue wheat, and red dot maize. So here is the mean difference of the effect of no-till over conventional tillage on maize. Here we can find on the left part of the graph, maize, wheat, and sorghum, and on the top we can see for the response for yield, evapotranspiration, and water efficiency. Okay, when we look at the maize, no-till increase the maize yield because evapotranspiration is crossing the zero line. No-till have no effect on the maize evapotranspiration, but increase the water's efficiency in no-till areas compared with conventional till for maize. For wheat, we didn't see difference in yield, evapotranspiration, and WE because all was crossing the zero line. And sorghum the yield was increased when sorghum was cultivated in no-till areas. Also, we found higher evapotranspiration and higher water efficiency using no-till sorghum in no-till areas compared with conventional till. I'm just showing here each dot that we just saw in that graphic was analyzed by we call this I just forgot now, but each one of that dots represents a bunch of studies that we run the meta-analysis. And here, for example, is the result of the first dot, where maize is increasing, no-till is increasing maize yield in no-till areas. And also we can see here the mean average in no-till compared with conventional till was 533 kilogram per hectare, higher in no-till areas. When we run separate, comparing single crop with crop rotation for maize, both no-till increase maize yield. Evapotranspiration, no difference, and water efficiency was increasing in single crop and in crop rotation. In areas higher than 600 millimeters and lower than 600 millimeters and higher than 600 millimeters, we found that no-till has no effect on maize yield, evapotranspiration, and water efficiency in areas lower than 600 millimeters, but in areas higher than 600 millimeters, we found higher yield, evapotranspiration, and using no-till compared with conventional till. Also, temperature was different when we compare areas higher than 12 degrees Celsius and lower than 12 degrees Celsius. In both areas, we found that maize was increased yield, no difference on evapotranspiration, and both conditions was increased water efficiency with no-till. And here we have comparing areas with no-till in 0 to 3 years, the implantations, 3 to 6 years, and more than 6 years of implantation. We found in the beginning 0 to 3 and 3 to 6 years of implantation, we found higher maize yield with no-till. And also we found higher water efficiency with the same range of implantation. Here for sorghum, when we have sorghum cultivated in area higher than 12 degrees Celsius, we found higher yield, evapotranspiration, and WUE with no till, and no difference when the sorghum was cultivated in areas lower than 12 degrees Celsius. And for the duration of no-till, 0 to 3 years we found, and more than 6 years we found higher yield in these areas, and also higher water efficiency when sorghum was cultivated in long-term duration. We found higher water efficiency with no-till. And here for wheat, when we saw the wheat results compared with corn and sorghum, wheat was not very responsible to the no-till. But what we can see in this figure was the duration of no-till had effect on the wheat yield, and also I think it was just we found higher wheat yield in areas with 3 and 6 years of implantation and more than 6 years of implantation. This meta-analysis allow us to evaluate a range of agronomic and environmental factors affecting water efficiency, evapotranspiration, and yield in the US. Yield and water efficiency are dependent on the interaction of climate, crop rotation, and duration of no-till. Our results clearly demonstrate that no-till increase yield and water efficiency compared with conventional tillage systems. Management with no-till increase average difference in yield and water efficiency of maize and sorghum compared with conventional till. No-tillage duration was an influential variable for wheat and sorghum, with increase in yield in no-till more than 6 years of implantation. Maize, for maize, the positive impact of no-till on yield and water efficiency were more evident on 0 to 3 and 3 to 6 years of implantation. No-till were more pronounced. No-till were more pronounced in areas with relative warmer climates, higher than 12 degrees Celsius, in area higher than 600 meters. This meta-analysis quantified the impact of no-till based on available scientific evidence, providing a base for improving no-till conditions in the US. Thank you. If you have any question,